Hi friends, this week we're going to venture back to quadratics. I know we kind of took a sidestep there with the linear inequalities, but we're going to jump back to quadratics. We're going to review a couple pieces. If you need to review factoring, you're going to want to check out the videos in the review work earlier in the plan just to kind of review. That's our generic rectangle. That's finding our numbers, kind of our diamond problem, using that to find our factors. So we're factoring our standard form, and then we were using the zero product property. So we're going to kind of review some of those pieces in this video as well. We're going to start this week just reviewing standard form. So ax squared plus bx plus c. So that's our standard form for a quadratic. In this video, we're going to review how to find x-intercepts, y-intercepts, and vertex of a parabola or a quadratic function. To find the x-intercepts, we're going to factor our quadratic, and then we're going to use the zero product property. And if you recall, that's when we set each factor equal to 0 and we solved. So we got two values that would make the equation equal to 0. We replaced y with 0 to start those problems. Y-intercept, that was the value of c. So we saw that right here in our standard form. Y-intercepts have an x value of 0. So when we plugged 0 in here and 0 in here, we would end up with those two terms going away and being left with c. And then vertex, when we found the vertex, we know parabolas are symmetric. So that vertex point, the x value fell in between the x-intercepts. And then we would take that x value, plug it into the quadratic equation and find out what the y value is. We also have another way to find vertex. We'll look at that in this video. The vertex, to find the x value of the vertex, we can take the opposite of the b value, so the opposite of whatever this value is in the quadratic, and divide it by 2 times the a value. So that's kind of unique. It's kind of, that's going to give us our x value of our vertex. And then we would take that number and we would plug it in to find the y value. So we're going to look at how we could use that in this video. All right, example 1, I have a quadratic in standard form. First thing I'm going to do is I'm going to write what the y-intercept is. So the y-intercept is going to come right from here. It's 5. So the y-intercept is going to be 0, 5. Now I want to find the x-intercepts. So to find the x-intercepts, we're going to factor. So generic rectangle, I got an a value of 1. So what multiplies to 5 and adds to 6? 1 and 5. So I would get x plus 1, x plus 5 equals 0. So that's the zero product property. So that's when we split these off and said x plus 1 equals 0, x plus 5 equals 0. So our x-intercept would be -1 and x equals -5. So those are our two x-intercepts. So we can put those here. We have -1, 0, -5, 0. Those are x-intercepts. Now for our vertex, we have to find the middle of -1 and -5. Turns out that's -3. So we know the vertex is going to have an x value of -3. And then what we're going to do is we're going to take -3 and we're going to replace it in for x in our quadratic. So -3 squared is 9. 9 plus 6 times -3 is going to be -18. And then we're going to add 5. So that gives us a -4 as our vertex y value. Now I'm going to key into this idea here just for this example. Opposite of b divided by 2a. If we do that, we should get a value of -3. So I'm going to sidestep that here. Opposite of b. B in our quadratic here is 6. So the opposite of that is -6 divided by 2 times a. And a is 1. So that would be negative 6 divided by 2, which is negative 3. And we see we got that same value for our vertex, and then we'd have to take that value and substitute it in. All right, let's look at another standard form. We'll do the same thing. We'll look for the vertex, the x-intercept, and the y-intercept. So right off the bat, y-intercept, 16. Or 0, 16, however you would like to write that. X-intercepts, we have to factor. Got an a value of 1, so I can see what multiplies to 16, adds to 8. It's going to be 4 and 4. So I have x plus 4 and x plus 4. This is a unique situation for us. If we look at the last problem, we had 2 x-intercepts. In this case, we're actually only going, because these are the same factor, we have an x-intercept of negative 4, and we have an x-intercept of negative 4. So in this case, we only have one x-intercept. So if we only have one x-intercept, that's going to tell us that the vertex is on the x-axis. So we'll see if that's true at the end. So our x-intercept is going to be negative 4, 0. And now let's look at the vertex. I'm going to use the opposite of b divided by 2a. So to get that first value. So the opposite of b is going to be negative 8. 2 times the a value, which is 1, gives me negative 4. So I can now see that vertex is my x-intercept. And when I plug in negative 4, I'm going to get 16 plus negative 32, which is negative 16, plus 16, which gives us 0. And that is that's just a review of standard form and finding those 3 important pieces of a parabola or the function itself. It is important to note that in that first example, we had a factorable quadratic, gave us 2 x-intercepts. In number 2, we had a factorable quadratic, gave us 1 x-intercept. Now, we're going to study a little bit more quadratics. We've looked at things that are factorable, not factorable. Just because a quadratic is not factorable doesn't mean it doesn't have x-intercepts. It just means those x-intercepts might be ugly. They might not be nice whole numbers, or they won't be nice whole numbers. It also means they might not have x-intercepts. So that's kind of what we're going to dive into over the next 2 weeks here. So hope this video helps. And next we'll be looking at a different form of quadratics.